Today is the 22nd of July. I spoke to the Green Carbon webinar a little over a year ago, was recorded. I have since then given one presentation to the Biochar Crusaders in India, but it was not recorded. And so I've actually taken a few of those slides and added them in because they're not generally available for everybody to take a look at. The presentation will be very fast. I don't expect your people to be taking notes because you'll have this on it. I've already sent to James Schoner the full slide deck, and it could be ready even by the time we finish. You can go back and get these. This would be from my website, not from Green Carbon, but that website will be shown also. Next, I got this thing here, wrong place again. All right. Yes, biochar is in its wild, wild west stage, and I'm trying to show you how the rock kiln can make some progress for everything here. First, a few things about biochar, some slides which have not been widely shown and should be up and around. I did this representation of all of the carbon dioxide removal methods, and this accentuates how biochar is a takeoff. It's an adaptation. It's a hybrid. It uses what comes from plant growth and puts it into the category of a more stable substance, which is biochar. This is a more complete diagram, and these are in some of my other presentations, which are at my website with further discussions. Here, they're just some of the summary types of things, showing it in there. And the large lettering in red is sort of the name of the 6 or 7 types of carbon CDR methods that we have, okay? This is a representation that points out the issue on the right-hand side, permanence, and that crops and things can decay within a year or two, or certainly by 10, and the long-term carbon compounds, inorganic compounds, that's long-term, but biochar is in this critical period from hundreds to thousands of years into it. So it's a clear winner for plants with biochar. The rock kiln technology has been explained numerous times before. It's at the website and around. It is a variation of a flame cap technology. It is, the predecessors are in there. Basically, it has some advantages over the open top flame cap, and they become evident as we go through our presentation. This represents 4 well-known known sizes of rock kilns. There will be more sizes. We'll be discussing these throughout the presentation. The approximate, what's shown here are diameters of 2 feet, 3 feet, 4 feet, and 6 feet. And certainly they will be built at 8-foot diameters and probably larger than that as we go to the big industrial purposes for it. The sizes, the rock kilns fill an important niche in the size categories. There are 7 orders of magnitude of input of biomass, and I based it off of 10 hours of operations, okay? And we will talk about the T-Lud cook stoves a bit today as one of the ways to make biochar in quantity. The rock kilns fill this major gap of the small, midi, and medium sizes, and but I'm not talking about the large industrial types. But we get quite large. The latest rock kiln innovation is the HFrame. I have a few slides about it here, and you'll see it elsewhere in the presentation. You can come back and to see this. Here's samples of the pieces and stuff on how it is made. It gets its name because looking at it from the end, there is an H formed by the cross piece that holds up the barrel, and it has a rotational axis for it. I thank Arizona State University and the interns there who are helping out with important diagrams. We will have more of that coming further on. So we're getting good into the engineering side. And look at the two pictures on the left-hand side. They are two frames, H-frames. The X is on the side, so this is not an X-frame. This is an H-frame because it's determined by looking at it from the end. What's the difference between the upper left and the lower left? It's the same kiln tipped on its side as shown on in the lower right-hand picture. Put on bigger wheels on it, and this thing lowers itself close to the ground for moving through. This is a variation of what was proposed several years ago, actually, of a field unit that would go through the field low and you could pull it in. It's different because it's now within the H-frame structure, far superior. I won't go into the learning curve that got me from this drawing over to what was shown in the previous one. But this is a way to facilitate the inputting if you're going through fields and you want to clean up the stuff. You don't want to be picking up the straw and putting it onto a wagon and carrying it someplace. This thing goes through the field, in the previous design with the H-frame. Some lessons learned thus far about it to save you some time. There's no need for a door. There's no need for a hood or chimneys. There's no need for the grate or bars. No need. Scrap metal works fine. Learn with mild steel. It lasts quite a long time. There is no insulation involved with this. There is no protective bricks and ceramics and things like that. No protective paint. Let the stuff just roll. So this is what you're seeing in these presentations. The website that's listed there, woodgas.energy, is the place to go. And at that website, there is go to the tab / the resources, and you will find numerous documents, and that is where you will find today's presentation, not the audio part, that's with Christian, but with just the slide deck, and it will be up there certainly by today, if not by the end of this session. So and that is also where you will find the climate intervention with biochar white paper that I wrote. Lots of information in there. Again, previous presentation stuff has gone through it. I am calling it to your attention. There are three very distinct operations that work closely together with rock kilns and others for biochar in a biochar project. You have the biochar production. You have to have the biomass. You have to pyrolyze it, document it, and you have to hold it. You have to be able to keep this stuff there. Second one is you have to get this sequestered into soils, making it unburnable. And there are extra advantages of this and benefits if it's going into the soil. So that's important. And the biochar carbon financing that can help make all of this stuff possible. We'll be talking about all of these. This is an operational structure for some biochar projects. In the center column, the project control, who are the owners, who are the managers, who's actually has the main control over this. We work with implementation partners. An example of this will be what Gilbert in Kenya represents with the efforts that we're setting up a business in Kenya and other places. They have local associates that are doing different things. These arrows represent the interactions between them. In the right-hand column, finance sources from different types, very important. They go through the control mechanism. The The biochar producers themselves with kilns or with the TLUD stoves, and they are in target communities. Fuel suppliers is definitely an important part. Any one of these is definitely into the commercial or the money-making business aspects. On the left-hand side, the lower right is we make these units, the stoves and the kilns with authorized fabricators. We can discuss about that. They get these to the house, to the users on the other side. And upper left, very important for the carbon dioxide removal records and processing. You'll be hearing today about CERCS App Ecosystem with CharTrac. There's a few slides about that, developed by James Schoner of BitMaxim Laboratories, who was one of the co-presenters with me for this presentation. This design is flexible and can work in different places. And you can find yourself in here. We want to talk. I'll work with you on to make things happen. The CERCS App Ecosystem with CharTrac. The climate change is with us. Carbon's the solution for it. And we need credibility about the removal of carbon from it, as well as credibility concerning the emission offsets. But we're talking about carbon as a stable form for long-term sequestration. The CERCS App Ecosystem includes comprehensive features. We've been working on this, James and I have been working on this since operational since 2018. I believe we were probably started in 2017, conceptually 2017, okay? So we've been at it for a while, but it is vastly improved. The CharTrac system is vastly improved as it's going into the CERCS App Ecosystem, all right? For anyone who is into the computer world and stuff, we think this is the place to be. Please contact us. We're happy to get you involved and to show you what's going on, and always looking also for investors. Here is a schematic diagram of the CERCS App Ecosystem. There are apps, meaning on tablets, on smartphones, data coming in, data going out, internet connectivity, sending the information around between the different components. So this is the modern way to do it, and blockchain is included. CERCS registry in the lower left-hand side, an important component. It is separate from the CharTrac, which is the sort of more in the field operational things. We could go on much discussion about this. So here is your first look at CERCS. About CERCS, every carbon offset can be traced to specific data. I'm actually going to change the word offset to mean also removal. Slip up on the wording. Let's make sure that we realize every carbon transaction, every carbon unit, it can be traced to its specific data. And the CERCS registry, when this is implemented, can actually do aggregation of fractional unit claims. Too many words in here for me to read through them and try to get understanding. They're on the screen. You'll be able to go back to them, study them up. If you are into the carbon world and the how this can be used for financing and stuff, you probably want to spend a few minutes on this particular page. At the bottom is the contact information for James Schoner. That's bitmaximlabs@gmail.com. I work closely with him. If you forget the address, let me know and I'll put you in touch with James. Now, this slide is going to be seen later on again, but it sets the stage for the rest of the presentation. These are implementation scenarios, and there are 7 of them represented here for carbon dioxide removal with biochar. On the left-hand axis, it is the situational resource level. It's the societal level. It's the high, medium, and low. It is developed world and less developed and struggling world, okay? Across the x-axis at the bottom, we have a logarithmic scale with how many units, operational units, are needed in order to produce, this is in the description down below, the number of 100 tons of biochar per day is you need X number of units, like up there for the large rock kilns, first one upper left, 20 to 40 units should be doing this. We're looking at a project in Quebec, which we'll hear about. On the other end of the extreme, with 100,000 units, you are also able to produce 100 tons of biochar per day. And we will discuss some of this a little bit more. The CERCS system will handle the small ones and the large ones of the sizes or the numbers. Now going into some of the applications and how this thing is going. Oops, sorry, I'm always checking my time here. On time at the end. A number of slides here about Kenya. Kenya is the leading position for making things happen. We're setting up a business in Kenya with Gilbert Mwenji, and he's the implementation partner. If you think back to that schematic organizational diagram that we had into there. He has TLUD stove experience from previous work. Now he's into biochar and the rock kilns. There, he has at his disposal already 5 rock kilns. There are 2 other ones in another part of Kenya. And all of them have wheels. They move through the field. You'll see some of these pictures. We are working with him on full procedures for it to be totally compatible with the CERCS CharTrac App Ecosystem. That's being refined as we speak every day as it goes along. Gilbert has been called out of the field today in order to be in attendance at this meeting. Here are several pictures that come from different stage. The rock kilns, before they had the HFrame, we used what was called the X-frame, and the X refers to looking at it from the end of the barrel. And there's a cross X into there. Note the different types of biomass which are seen in these pictures. Gilbert has been making biochar now for several months in Kenya with the rock kilns, the X-frame and the H-frame, different types of biomass that you can see some of them into there. With the wheels, they pull it through the field like in like a wheelbarrow, a double wheelbarrow. We're working on all of the issues of user friendliness, how to do it. The unit in this picture does not have wheels. It's one of the other systems, but I've included it because it shows successful making of biochar from rice husks. And the secret of success of rice husks is they need the continual feeding in small quantities. You cannot dump in a bag and it's going to suffocate it. But if you've got either a mechanized system or if labor is inexpensive and you're putting it in, you can certainly make biochar out of surplus rice husks. We are not trying to save and utilize the heat that comes from these rock kilns at this time. That will come along as we, with more development. Excuse me. The next slide. Also in Kenya, more pictures of units working. The paint does not last on these barrels. It will always come off. There's not a, and we're not trying to powder coat them and things like that, but they hold up, they do well. Just some pictures there for your viewing pleasure. More samples, some of the biomass there's putting in, small stuff, grassy things, leaves and stuff like that in some of the other pictures that you'll see. The work with wood is not common in Kenya because of deforestation issues and stuff. We are using pretty much waste biomass or nothing's waste, crop residues. A very recent work that he did, upper left, It's smoking in part because he didn't have a chance to let it adequately dry. It's got a little bit of wetness to it, and that cuts back on different things. He takes the char from the kiln, he puts it into buckets, and you can see the scale hanging that's above the bucket, a digital scale. He gets the weights down. I've added some typed in notes on his page of notes into there, and it totals up to 5 hours and producing 42 kilograms of char, and those kilograms actually nicely fill a 55-gallon drum which is on the right-hand side. Put a lid on it, smothered it out, and able to then put it into sacks the next day, things like that. So the techniques are all being worked out, applicable in every country, in practically everybody's backyard. I won't say that, shouldn't say that. Some people are living in close proximity to neighbors, but most places it's very valuable. Any place is rural, certainly. Okay. And this puts down, there's some numbers later on cost structures and things. In the United States, I have done work when I process approximately 25 kg of woody biomass per hour, or a quarter of a ton in 10 hours. That's that back on that chart of the sizes and throughput in it. Getting 50 kgs of biochar, you run the numbers through there, and we're actually coming out with about a $12 gross income if we are able to collect the $100 per ton of CO2 equivalent, which is what Microsoft, Shopify, and others they're actually paying much more than that. And half of that $12 or $6 a day can pay for an agricultural worker in many countries. These projects are definitely financially viable, sustainable, creating jobs, doing all the good stuff that it's supposed to do, plus the biochar benefits. And after you collect the carbon credits, you're able to still keep the char to use. I have some operational notes on it. When all of these things are being developed up, there'll be separate reports written out all through that website I've given to you previously. For example, in Kenya, we have a number of items which are supporting materials: the scale, the bucket, the barrel, a pitchfork, shovels, measuring tape, notebook. We're listing all that out. This work is being done, and it is shareable to anybody and everybody who wants to get into this type of situation. Especially, I hope we have some friends on here from Biochar Crusaders in India. Many of these comments are directed very specifically to you. Let's make some things happen over there also. All rock kilns are owned and controlled by the Kenyan business, or by the business in the local area, with signed agreements by the suppliers concerning the kilns, etc., and for CERCS CharTrac. It's all possible. These are going to be locally owned and operated with participation. I will be participating in some of them, to be defined. Final thing, decentralized, locally focused implementation is what we're looking at. This business model will enable rapid scale up by replication, a franchise model. There is no reason for people in Zambia or Paraguay or someplace else that to not have the same types of things which are going on in Kenya. You don't have to wait for Kenya. You don't have to wait for other things to be done. I'm hoping there'll be some people who want to get moving on things after this presentation. Here, there's a project in Mexico, and it has an extra long barrel. Actually, I don't have a picture of the unit from Mexico because it's 3 barrels long, and it's supported in an X-frame arrangement. This particular one is in Kenya, and it is 2 barrels long, and it's ready to go. It can do its work. we're looking at issues of reinforcing. We are not limited only to a barrel, but this is sticking with the convenient size, just is 23 inches, just under 2 feet in diameter, and then we can make them long. We certainly have already been made and in use for 3 feet long. The Mexico work is working with coconut shells, and I say that it is a industrial production because they're looking at exporting of biochar to other countries, to other purchasers into there. In Mexico, my participation partner there is Ken Reeves, and I will, I'll play just a little bit of this video.
Mr. Anderson, this is all, everything is burned completely. Unfortunately, we don't have enough bags to start putting it.
He doesn't have enough bags of coconut shells to put in to keep that demonstration going. So you can look, it's a little bit more time than that, but we don't need to emphasize it there. It's there, it works, and it's functional. Did I miss one? No, okay. Industrial production of biochar in the USA. I'm very sorry, but the client is confidential. A very specific biomass. We're looking for quantity throughput. If you're interested, if you've got $1.5 million to $2 million and want to get into something, I'm the contact person for it. But they'll know that I'm talking about them once they see this video. Okay, so it's action. Things are happening. Now, up to the larger, and that unit could be a larger unit, that one I was referring to. This is now several slides about forestry biochar and using Quebec as an example. In the bottom of the sheet is Dr. Benoit Lambert's name and phone number, and you can contact him through me. We have a working relationship for Quebec and the Maritime provinces. Forestry residues, large rock kilns. The largest one, which you're seeing here, is 6 feet by in diameter. You can stand up inside of it, and it's 7 feet long. Produces approximately 1 ton of biochar per day. We're looking to enlarge this to at least to an 8-foot diameter and a 20-foot long. Think of a 20-foot shipping container, but it won't be sideways. This way, it'll have other ways on it. We don't know how large the size can go yet. We don't have the resources to just keep building sizes and building bigger ones. We're looking for investors here for the Quebec project and also for large units in other countries, other forested areas. I certainly hope that the U.S. Forest Service and the Agriculture Service takes notes of this. We would love to have some projects going on. We're spending our time on making things trying to happen. This is also a video. That noise was a truck going by, okay? So this is a rotatable covered cavity kiln. It is not rotating all the time, but it can be rotated, and that's what gives us the mixing, which is so important to be able to accomplish good biochar production. Time, temperature, and turbulence. We have turbulence with gravity as our partner. The picture on the lower right-hand side is the char inside of that kiln after it's been produced before it was being dumped out. Oops, oops, I got another one here. Here are some others. You notice that this is inside that shipping container. It is rolling on rails. It is automated. You can see the gears on it, electrical stuff, and it will, when it comes time to dump it out, it rolls over a hole in the floor and it discharges. This char is not ready yet to be discharged. This is just for the sake of the photograph. We would have the char and then it's emptied out. We don't empty out flaming masses of biomass in large kilns like this. A diagram of the building of it, the shipping of this inside the container, a great learning experience, something that we're going to be using for our testing work with large log diameters and things, because the forestry projects is going to be making things without chipping the wood. I mean, they spend thousands and thousands of dollars for chipping trees and timber just so that they can make biochar. We use the actual timber as shown in this particular picture here. Also, a large kiln we expect to produce 2 tons of biochar per day, probably the 10-hour day number that I've been talking about, but we could have multiple shifts if we needed. But with 2 workers and forestry equipment, and they could operate 2 of the large rock kilns, giving us 4 tons per day with a team of 2 people. 25-ton teams with 50 rock kilns could produce the 100 tons per day, which is 250 tons of CO2 removal per day. If we are able to get the 100-ton mark, and Microsoft actually pays more than that in the early development stages and things, but that's $100 per ton thing. This is about $25,000 per day, or $1,000 per team, to cover the labor, the equipment, the support, and we think it can be increased. This is to be worked on. When we're ending up with land which is cleared from biomass, which is both a fire hazard and it occupies land where they want to plant trees, and we still have the biochar to sell after we have been able to document using CERCS CharTrac that we have made this biochar and it is permanently sequestered. The implementation partner, Benoit Lambert, there's his number again, or talk through me. We are looking for financial investors, financial partners, find different ways in different things. And his relates to Quebec. I'm dealing with other areas also. Environmental management. Think of the fire-prone western areas of the USA. Lots and lots of wood. They could be doing things with that unit the size of what we had for Quebec, but it could be also this 4-foot diameter size, which is shown, and there's videos of this at the woodgas.energy website. This is the unit that's out in California now, and much development has gone on since then. This is big time. We need this. I'm looking for people down under the challenges. It says need sponsors with resources. Yes, work with, we're going to minimize the emissions. This is using the hood. That helps. There's our advantages that we're doing. And in red, handle the bureaucracy. To be quite honest with you, California or any of the states out there makes it extremely difficult for me and people that I'm working with there to get some traction. We need some help. Just if you can handle the bureaucracy, and we'll be able to make things go forward. If we're also able to utilize the heat, that's good. This also refers to urban areas which have tree trimmings or orchard trees where they have their cuttings that have to be looked at. So many options. Please just give me a call, contact me. Personal pyrolyzers, occasional users. This is reference to the people that want to make it every once in a while. They'll have their own unit, more like in affluent societies, and people will have one. And the note says you can actually make it into a grill after you make your biochar. And I've done this. I put a grill in it, and I've done a Brazilian, my wife's Brazilian, a Brazilian style barbecue over the coals inside of that. And after I've cooked the meat, then I dump out the coals, and I'm able to have saved my biochar. The unit in the lower right-hand side is the one by Gary Gilmore. He's the co-inventor with me. I credit him with significant inputs for the rock kiln. So there are issues on it. We'll find out how to do it, this aggregation stuff. These are challenges, but hopefully people will participate. This table is superseded, but it's in here for a reference at some time. more likely it is this selected sizes of rock char makers, rock kilns, and different numbers into there. Obviously, I'm not going to go through all of those. This is something you go back and look at. Hypothetical scenario for a utility-sized rock kiln, 4-foot diameter, 8 feet long, and put it in with regard to it. We get some numbers out from into there. Lots and lots of work has been done with regard to this. Now I'm going to shift over to the small side of it, the micro side of making biochar, and it can be done, accomplished nicely in T-Lud cook stoves. T-Lud stoves are the only ones that are seriously carbon negative with making biochar. You can get some charcoal out of a rocket stove, out of some of these other ones, but you're not getting serious biochar prepared with the pyrolytic processes and things like that. This project in India is, the note says, is ready for instant start, payback in a few years. I am looking, there is a write-up about this in my white paper in section 12, and it's ready to go. Some billionaire, some wealthy company that wants to make a mark in the world and show that it's good and humanitarian minded and using its wealth. How about helping out some tens of millions of people who are still cooking over a wood fire and move them into the realm of gasifier cook stoves? It is not that expensive and it pays back the investment. This is money making by doing humanitarian work. I hope somebody, if you know somebody who's got money, if they want to be anonymous, fine. If they want to have their name up in lights, I'll put it in lights. That's we need some sponsors, and the stuff is written out. I've written about this before. Please contact me. The partner that I work with, the implementation partner in India, is Mulindu Banerjee, a key person, extremely a competent person in what we're dealing with. On the T-Lud stove side, we also have the forced air versions, and I'm talking about the Fab stove in particular. Go to any country. In fact, the one that's in red with the red base there, that's for sale in the United States. It's American prices and it's imported and it's all assembled and everything else, and the price is $199. And from Blue Sky Biochar, and this is the upper left, forced air base, that's FAB, in a Fab stove makes it fabulous. The fan is in the base, the fuel canister, it comes in and out. It is replaceable and in multiple users and stuff. We have some different designs of the 2-burner unit, and the Dave Lello is the key person for this. He is in South Africa. I work closely with him, and this is designed for using with pellets or coconut shell pieces, which are also densified, or dense, not densified, but dense biomass fit into there. You can get an hour's burn, a beautiful fire. At the Blue Sky Biochar website, Michael Whitman has a beautiful video that shows the Fab stove, the red-based version, which is the one that's imported, and for America. So we're looking for funding for scale up. Always all these types of operations, or in any country. We are talking about a project in Venezuela with the Fab stove to be made mostly in Venezuela, eventually totally made in Venezuela, shipped in flat packs, many different angles and things which go along with it. Yes, I'm watching my time, and I'm going financing of biochar carbon dioxide removal units. CDR, carbon dioxide removal. I like to put an S on the end of it to emphasize the long-term storage, but it's all either way. Normally removal implies the storage, but if you say that CDR includes forestry and Afforestation, well, the tree is growing fine, but it doesn't have the long-term part. So CDRS, I like it to emphasize that. 1 ton of carbon dioxide equivalent, securely sequestered for at least many hundreds of years. You only need 400 kilograms of biochar to make a ton of CO2. After adjustments, 1 ton of biochar is going to give you 2.5 tons of CO2, and the price of that is listed out and working on it. Microsoft has announced its request for proposals, and in case anybody is wondering, yes, I will be putting in proposals to Microsoft for carbon dioxide removal funding associated with rock kiln projects, and also for the TLUD stove projects like the one in India and the Fab Stove. Anyone interested in participating, again, just be in touch, please. That slide I showed you previously, and there are 7 groups in there, sub types into there. The upper right-hand side, it says 250,000 barrel-sized rock kilns used by occasional users. I don't know how many barbecues there are, and there are in the United States, but there's a heck of a lot more than 250,000. I mean, they're in the millions, okay? When many, many people are doing things, we will come up with quantities, and we bring this together. We are after carbon removal from the atmosphere. We've talked about these different sizes into there and how many are needed on each one. The Fab Stove and the Champion Stoves are listed out into there. And any one of those at those number of units in there represents approximately $25,000 per day of cash flow, or the carbon dioxide removal carbon credits that could go with it, which comes out to a roughly $9 million per year if you can get the $100 per ton, and some of it will be higher than the $100 at the beginning stages. And then the bottom line, you still keep the char to sell, but just so you don't burn it. That's your contract. It will be sequestered into the soil, help your garden, help the climate, all this, and make some money. I'm not in it for the money, I'm in it for the impact, but the money sure helps make things happen. This next diagram here, same thing, but I've changed numbers on it. This is giving you the approximate costs of these units, whether it's $80,000 or whether it's $40, that's the two extremes of the chart. What in the end, in the lower left-hand side, a very interesting number which I've come across, needs to be verified more fully, but we have enough to make, I can make this statement. The investment costs for each of the sizes, associated with each of the sizes of rock kilns, are similar per annual ton of biochar production. And that means that about $40 per annual ton of biochar production. One cook stove will do about 1 CO2 carbon removal per year. And one of the large rock kilns, hey, it's going to take out a heck of a lot more, but when it comes down to the cost per ton of biochar, it comes out about $40. Now, this is a draft document. It is very much subject to change, but I think we're on the right ballpark, in the right ballpark for it, okay? Presentation summary. We've talked about the CDRS removals and the kilns. We've talked about CERCS App Ecosystem with CharTrac. We've talked about projects, Mexico, Kenya, Quebec, USA, India, elsewhere. The global transition from fossil fuels means trillions of dollars of new economic activity. The fossil fuel industry is, it's not dying. There's going to be some stuff that's going along with it, but it is on its way out. In India, all of the efforts to have people shift over to propane cooking stoves, and we're cooking on wood, will need to be reversed if India is to be net zero by 2050. That means no fossil fuels, and these people will be going back to cooking with biomass that they're currently using, and they're doing all the efforts to take these people away from it to put them into fossil fuels. That's business, folks. I can't, but the gasifier cook stoves, the T-luds, answer that. The rock kilns should be giving us heat for our houses, for central heating districts and things like that. You're invited to participate in these big industries and stuff. Business possibilities, I'm going to leave this most for people to look through, but no rock kilns are sold. They are operated under a patent, under a lease from me with licenses, agreements. We'll work out something on it. I have patent pending status on it, and for what does that mean? And the results, by examiners are very favorable for this patent being issued. A patent is a legal monopoly for a limited number of years. So the rock kilns until 2040 will be handled by working with me, and believe me, I want to have this easily available for everybody, not holding back on stuff. We're looking at this in some of the next slides saying it in here. There are business possibilities for fabrication, for management of units, for use of the kilns, the resultant carbon-related impacts, and see me about some of that. The manufacturing examples for business, the research and development type of stuff. You can have projects putting this in. There's grant money out there for it. If that's put me on your team. I'm willing to work with you. I can bring all the technology to you. I want it to be there, no holding back. Operate the businesses with char production. You can do biochar for commercial products, making it with compost and mixing it. That's not production, that is processing. And the transaction with the carbon markets. The climate crisis $1 trillion section, and CERCS, I've mentioned some of that before. I want to point out that are with these agreements, but I'm open to all things that are coming with it. The second item in here, when there is financial gain, that means by you, there's something going on, you're not padding the books or something like that, but you're actually, people are getting jobs and getting things going based on rock kilns, then and only then am I looking for something back. Get started with it. I'm not holding you back. Please don't cut me out, but working with you there's no upfront fees to get involved with this. All options are open for business arrangements. You're encouraged to become involved. Costs of the kilns, I'll leave them into there. We've done some of that stuff before. There's even do-it-yourself style. No problem. You're not doing it for profit. You're doing it to make something. If you start making them for other people, that's a different story. But yes, let's get this going and make them and have them. If you're interested, if you're a builder on it, this is prospects and abilities. We'll have questions into there. I think that was my last slide. So I'll just go back and leave that up to that. Christian, I can't believe it. I made it with 7 minutes to spare. I apologize for not taking any break in the middle. If people are still on the line and not shaking their heads and stuff, we'll throw it open to questions. The email contacts, this is my mobile phone chat, WhatsApp number is up there. So we'll be hearing from some people. So maybe I should say, if there's anybody, my co-workers, James Schoner and Gilbert Wanji, if they want to say something also, but I will actually go mute here and let some people do some talking. I can go back to any slide that you want, okay?
First of all, thanks, Paul. That was a